Simple or primitive unit cell. So what we meant by simple or primitive unit cell means this is a cubic cell. We are talking about cubic cells. So the atoms in that cube will be on the corners. Atoms will be situated at corners. So let's see. Imagine a cube. So according to rule 1, atoms should be present on corners. So how many corners are there for a cube? 8 corners, obviously. 1, 2, 3, 4, 5, 6, 7, and 8. So atoms are present at the corners. So if one atom is at the corner, let's say this one, check this one, whether the atom is completely inside the unit or not. No, some part of that atom is inside the unit cell and some of the part is out of that unit. So let's calculate how much part of the atom is inside the cell. So up to now what we got, 8 corners. Fine. So how much amount of atom is inside the unit cell? First let's calculate that one. So by looking at this one, what we understood, first point, half of the atom is out of the unit. So we should not consider the half part. So let's consider the other half. So this one, this half. So consider this half. I'm considering this half. So exactly at the center, atom is present here. So if we draw lines, so this line is nothing but this one. So if we draw like this, now see how much part is present inside this this unit. Only this much, this part is present inside this one. So this is also not at all half. First of all, not fully present inside that cell. And one more thing, half is also not possible. 1/4 of the half is present inside that unit. 1/4 of half part is present coming into the cube. So for half part 1/4, so full parts 1/8. So understand this one. Here atom is not at all completely getting into the cube. Half of the atom is outside that unit and half is inside that unit. And that too not exactly half is inside that unit. Only 1/4 of the half part is inside that unit. So total 1/8. 1/8 parts of that atom is present inside that cube. So if we consider 1/8 here, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, and 1/8. So 8 into 1/8. That is 1 atom. So simple or primitive unit cell is having 1 atom. 1 atom per unit cell in a simple primitive unit cell. So simple one is having one atom per unit cell. This is nothing but rank of the unit cell. Rank of the unit cell is nothing but atom per unit cell. That is nothing but rank. So this is about simple or primitive unit cell. So let's see other unit cells based on the atom rearrangement. Next one is face centered. Face centered unit cell. So in this face centered unit cell, atom should be obviously at corners as well as on faces also. Center of the faces also. So we understood how many corners? 8 corners. So if you take once again the cubic structure. Obviously atoms should be on corners. So 8 atoms, 8 corners. And one more thing, at the center of the faces also. How many faces does a cube have? 1, 2, 3, 4, towards B and towards opposite. Towards B and opposite. So total 6 faces. So total 6 faces. Corners 8. So we know by looking at this previous one. So 8 corners. So 1 by 8 part of the unit cell is atom is coming into the unit cell. So corners, how many atoms will be there? 1 atom. Then what about faces? How much amount of atom is coming into the face? So let's see this one. So 6 into only half part means if consider this one as a cube. So if we are placing any atom here, half of the part is coming into that unit, half is outside the unit. So half only is coming into the unit. So for one face half, so 6 faces, 6 into half, that is 3 atoms. So total 4 atoms will be present in case of face centered unit cell. This is also rank. This is about face centered unit cell. Next one, body centered unit cell. So in this case, atom should be at the corners. That is compulsory for any sort of a unit cell at corner, and that to 8. 8 into 1 by 8, that is equal to 1 atom. And next one, inside the body, inside the cube, inside the body, inside that box, inside the body. So same thing. So corners 8 and we are dropping one atom into the body. So completely it goes into that box. Into that box. So inside the body, 1. So total is 2 atoms. This is also known as rank. This is about body-centered unit cell. Atoms should be arranged at corners, placed at corners, and as well as inside the body also. So we know at corner, 8 corners are present. 1/8 of the part of the atom is coming into the unit cell. So total amount of atoms is 1. And as well as we are putting one atom, or we are throwing one atom into that box. So completely it goes. So 1 atom into the inside the body. So total amount of atoms is 2. That is rank. Next one, last one. End-centered unit cell. End-centered unit cell. In this one also, at corner and at end. Ends of unit cell, or else we can say opposite sides of faces. Opposite sides of faces. You can consider this face and this face, or else a top one and below one, or right face or left face. You can consider anything. So this is common for everyone. 8 into 1/8, that is equal to 1 atom. So what about this one? Opposite faces. We can take here. We can take this face or this face, or else this face or this face. So 2. So as I told you earlier, in a face-centered unit cell, half of the part is coming into the face. So 2 into half, that is equal to 1. So total is 1 plus 1 is 2 atoms. This is also rank. So this is about rank. That is very important. While we calculate the packing efficiency or packing fraction, we'll consider these ranks.